materials. In this strength of materials, we are going to see the number of topics from the strength of materials. So today I am going to start with the simple stresses and strains, where we are going to study what is meant by stress, the unit of stress, what is meant by strain, types of strain, unit of strain, and the relation between stress and strain. These things we are going to cover in this lecture 1. Now we'll start what is meant by this stress. So for that, consider one material subjected to force. Suppose this is the material which is subjected to a random force. Now if I resolve this force along the axis and perpendicular to axis, then its component will be, the first component will be vertical and the second component will be horizontal. So after resolving this R, we will get the two forces. One force is along the axis and second one is the perpendicular to axis. The force which is along the axis is normally called as the axial force, and the force that we consider perpendicular is called perpendicular force, or we can say shear force. So the forces which are along the axis, it may be tensile or compressive, and the force which is perpendicular to axis is the shear force. Means there are two types of forces. First one is the axial force and second one is the shear force. In axial force, suppose if I apply the force on the material and if the material gets elongated, means if its length is going to increase, then this force is called the tensile force. And suppose if I apply a force where the length of this specimen gets reduced, means it is compressed, then it is called a compressive force. So there are two types of axial forces. It may be tensile and compressive depending upon the elongation and compression, and the second one is the shear force. Now in this shear force and the axial force, we will see how the stresses are developed inside the material. So when I apply this force, so now I am going to draw the same figure but in the horizontal direction. So suppose this is the axis, and if I apply the force on this material, suppose tensile, then inside the material to the applied force, suppose this is the force, then material generates opposing force. So this is the opposing force which is generated inside the material. Suppose this force I represented by R. So if I represent this force by R, then this force F is equal to R. Means applied force will be equal to the resisting force. Means in any material, when I subject or when I apply any force on that material will start to oppose that deformation. So the opposing forces will be generated, and these opposing forces will be equal to the applied forces. So this thing is going to happen in axial force also and in shear force also. Means the applied force is always equal to the resisting force, but up to a certain limit, because after some limit this material starts to fail. At that time the applied force will be greater than the opposing force. Now, so all the laws that we normally learn are up to the elastic limit. Means when the force R, that is the opposing force, that equals to the applied force, up to that particular point we apply all the laws. Now we'll see the concept of stress. This stress is nothing but the ratio of opposing force divided by area. Actually, it is cross-sectional area where this opposing force will be generated. Means stress is nothing but the ratio of force applied to the cross-section area. Now, the opposing force that we applied here in this example, it is R, and consider this area of this section is A. Means it is nothing but the force divided by area, and up to a certain limit this R is always equal to applied force. So we can say that this stress is nothing but force divided by area. So the definition of stress is, it is the force applied per unit cross sectional area. Now if I consider this is the formula, then we can write the unit. Now how to write this unit? See, the unit will be, here we have force, and the force, unit of force in SI unit is Newton, and the area means length into width, so it will be meter square. So the unit of stress is Newton per meter square. Normally this Newton per meter square is called as Pascal. It is called as Pascal. Now in some numericals we will require the conversion of unit. So simultaneously I am going to write here the unit conversion. Now why unit conversion is required? Because in most of the cases the length of material is provided in mm. So we will have to convert this Newton per meter square into Newton per mm square. So to convert that, consider this is the n. Now in denominator we will have to replace this meter into mm. So 1 meter is equal to 1000 mm. So the unit will become Newton divided by 1000 mm. Now here we have meter square, so ultimately it will be 1000 mm square. So Newton divided by, this is the 10 raised to 3 raised to 2 means 10 raised to 6 mm square. So transfer this 10 raised to 6 on other side, so it will be 10 raised to 6 Newton per meter square will be equal to Newton per mm square. Now in technical language this 10 raised to 6 is called as mega. So this is the mega. Newton per meter square is nothing but the Pascal. So megapascal is nothing but equal to Newton per mm square. And this conversion we always require to solve the problems from the strength of materials. Okay. So again we'll see what is stress. Stress is nothing but the resisting force per unit area. Means simply we can say force per unit cross sectional area is nothing but the stress, and the unit of stress is Newton per meter square if you consider in SI unit. Now we'll see the second term, that is strain. Now what is the strain? Strain is nothing but change in length divided by its original length. But there are two types of strains. The first being longitudinal and the second one is lateral. So there are two types of strains. Now we'll see what are these two types of strains. So consider the same, but I'll show the cross section of that particular specimen. So the same specimen is shown, but with respect to cross section. Now if I apply the tensile load on this specimen, then its length will increase. Now after increasing the length, suppose the original length of this specimen is L and after the application of force, its length is increased by delta amount. So the change in length is delta. Now the strain in this material, we can say that it is change in length divided by original length. But when we consider along the axis, then that strain is nothing but the longitudinal strains. And if I consider the strain along the cross section, then that is called the lateral strain. So here we can write longitudinal strain as change in length upon original length. So delta by L is nothing but the longitudinal strain. Similarly, we can write for the lateral, but for that we will require the cross section dimensions. Suppose its cross section is diameter d. So when the length will increase, ultimately the diameter will be decreased. So here I can write change in diameter, or we can say change in cross section dimension divided by original cross sectional dimension. So here we will have to determine the change in diameter and divide by the original diameter. This will provide you the lateral strain. Now we will see the unit of strain. Now the unit of strain is, see, the change in length, means we will have to measure the length in SI unit. The length is in meter. Divided by original length, again we will measure in meter. So meter will get cancelled, it will be 1. So normally this term is called as unit less. Unit less means its unit is 1. So the strain is unit less quantity and stress having unit Newton per meter square. Now there is another one term normally learned along with the stress and strain, that is the Poisson's ratio. Now what is this Poisson's ratio? This Poisson's ratio is nothing but the ratio of lateral strain to the longitudinal strain. This ratio is called as Poisson's ratio. This Poisson's ratio is normally denoted by mu or sometimes 1 by m. Okay, and if you consider the unit of this Poisson's ratio, then it is unitless. So see, we have seen the three terms. The first we started with the stress, then we come to the strain. There are two types of strain: longitudinal, lateral. Longitudinal is along the length, lateral is perpendicular to length, and the Poisson's ratio. Now when we see or learn stress and strain, along that we require one more term, and that term is the relation between stress and strain. So I'll write here the relation. See, this relation is given by the Hooke's, so it is called Hooke's law. And that Hooke's law is, up to elastic limit, the stress in any material is proportional to strain. So the stress in any material is proportional to strain, but it is up to a elastic limit. Means initially we have seen up to a limit the resisting force is equal to the applied force. Means up to that limit we can say the stress is proportional to strain. So if I remove this proportionality, then we will have to put one constant, and that constant is modulus of elasticity. So stress is equal to modulus of elasticity into strain. This modulus of elasticity is also called as Young's modulus. So this relation will provide, or this formula will provide the relation between stress and strain. In next session, we will see the stress strain diagram for different materials. Thank you.